Greetings. My name is Sean Jones. I work for the Los Alamos National Laboratory as a member of the Research Library Prototyping Team. I'm also a member of the Web Science and Digital Libraries Research Group at Old Dominion University. And I thank all of you for coming to my dissertation defense. I'd also like to thank the IAPC, SIG-IR, the Mellon Foundation, and IMLS for funding portions of this research. And I'd like to extend my personal gratitude to the committee for participating in this evaluation and reviewing my dissertation, because I know it's a lot to go through. So today I'm going to talk about improving collection understanding for web archives with storytelling, shining light into dark and stormy archives. First, we're going to cover motivation and research questions to try to describe why we're doing this. Then I'm going to get into background and related work. Then there are different processes for storytelling that we'll go over. And then I'll close with contributions and conclusion. On November 8th, 2019, intelligence reports in the US noted that there were internal Chinese communications that warned of a potential novel coronavirus pandemic coming out of Wuhan. COVID-19 was not named and was only known to a small group of people, and no news coverage existed. On December 16th, the first documented COVID-19 hospital admission occurred. But still, nothing in the news. 1 month later, CNN carries a coronavirus category on its front page. Another month goes by with more front page articles about coronavirus. A month later, CNN had many front page articles about coronavirus, with even a special coronavirus section for more articles. A week later, states are locking down. A week later, the US has the most cases of any country in the world. I was able to tell this story thanks to a web archive. These mementos are stored in the web archive. Mementos are full captures of the web code that existed at these dates and times. So what other stories can we tell with web archives? Natasha is studying how disasters shape cultures. Today, she is reviewing the South Louisiana flood of 2016. Now, sources like Wikipedia contain a summary of the event after the fact, but she wants to know about the news reporting as it was of the time of the event. Per Nawala, news articles about the event tend to slide down search results as we get further from the event. I searched for something about the South Louisiana flood 2016 recently. And as we see, there's a number of summaries about the event I outlined in red. And green includes coverage of the event. Natasha also knows that news articles are updated with more current and correct information. As we see on the left, we have a Guardian article that was written about the South Louisiana flood during the event, where we have 7,000 people who were rescued. On the right, we have the same article today with a different title, different caption, more images and video, updated numbers, and new text that was not in the original article. We want news articles to be updated, but we also need a copy of the article from the time of the event. Natasha knows that anytime we need proof that X said Y at date D, we need web archives. To start, she must know a URL and a date time, and then she can view a memento, and then she can review the code if she wants to. Natasha also knows that archivists create web archive collections based on a theme. They go out to the web in the perpetual now, and they select pages based on a theme or topic, and they put them together into a web archive collection as mementos. And so we can see the pages as they looked at that particular time. With these themed collections, she can discover documents that once existed and match her event or topic. And these collections include things like the University of Utah capturing its web presence over time, or the Virginia Tech Crisis, Tragedy, and Recovery Network, which tries to capture coverage of various events in history as they occur, like the 2011 Tucson shootings. And Natasha's discovered multiple sites with themed web archive collections, sites like Conifer and Archive It, which is a subscription service by the Internet Archive, and Trove and the Library of Congress. So she chooses to look through the themed collections at Archive It, which again is a popular subscription service maintained by the Internet Archive. These collections consist of seeds, which are web pages we intend to capture. Mementos are observations of a seed at different points in time. And as we see with this example that I've outlined in red, this seed, consisting of a URL from actionnews17.com, has 7 mementos. It was captured 7 times between 2016 and 2018. And there are multiple collections about the subject, so which one should she work with? I show 2 here about the South Louisiana flood of 2016. This is not the only disaster she's studying. She's studying a variety of topics and needs to waste as little time as possible. And Natasha's not alone. 44 archivic collections match the search query for human rights. Which one is best for her needs? How do we know how they're different from each other? Let's take a look at Rustam. Rustam needs to study how the Boston Marathon bombing unfolded. By reviewing different mementos of the same seed, Rustam can understand what the public learned, including when misinformation was corrected. In this example here, I show the same seed, but with different mementos captured at different times. The Boston Marathon bombing happened, and then the manhunt started. So we have a memento from April 19th, 2013 at 1712. They're searching for suspects. The city is on lockdown. And then we have a memento from April 19th, 2013 at 1759. There's an officer in the hospital. The lockdown's been loosened, and people are wondering if the Red Sox game is going to happen. On the right, we have a memento from April 21st, 2013 at 2:24. The suspect has been found. Unfortunately, an officer lost his life, and President Obama is speaking. Rather than digging through collections manually, how can Rustam discover and view this more quickly? Olayinka wants to understand what different news sources revealed on the same day. Today, she's trying to understand the different reporting on the September 11th attacks. How can she discover and view this more quickly? Elbert is an archivist who wants to promote his collections so others are aware of them. He wants to help people like Olayinka and Rustam and Natasha. How does he create enticing visualizations that people can understand with minimal effort? Ling is an archivist who inherited a collection from another archivist, and she needs to understand it so that she can maintain it and make additional decisions about it. Her collection has hundreds of thousands of seeds, and her predecessor did not provide a lot of metadata. And as you see in this example, this collection has no description, which is unfortunately all too common on Archivit. Archivists can add metadata, but as we show with this visualization in the upper right-hand corner with the red arrow, the more seeds a collection has, the less metadata there is. And this is paradoxical because the more metadata a reader needs to understand a collection, the less they have available. And Ling knows she's not alone. Andy Jackson, the web archiving technical lead of the British Library, has stated, "We don't even know what we've got, especially for messy collections like web archives." All these personas need a faster method of collection understanding. Natasha wants to quickly compare collections. Rustam wants to follow a source over time. Olayinka wants to understand a collection or understand a time from different sources. Elbert wants to promote collections and help visitors understand them. And Ling just wants to understand a collection that she inherited. All are faced with more than 14,000 collections at Archivit, more than 14,000 and growing as of the end of 2020. The problem is that there are multiple collections about the same concept. It's difficult to easily expose aspects of collections. The metadata for each collection is non-existent or inconsistently applied. Many collections have thousands of seeds with multiple mementos, and thus you get this multiplier effect of potentially hundreds of thousands of documents that one would have to go through in order to try to understand a collection. Human review of the mementos for just one collection, let alone comparing 2 of them together, is an expensive proposition. So our proposal is a visualization made of exemplar mementos, exemplars that represent the collection well and convey what it's about. Our visualization is a summary that will act like an abstract. To borrow from Parolian Card's information foraging theory, we want to maximize the value of the information gained from our summaries and minimize the cost of interacting with the collection. And to ensure that mementos, or that users will understand that the mementos of the collection will address their needs, we have to ensure that our exemplar mementos have good information sent. So we want to move from this, as we see in the middle, a collection of more than 2,400 mementos about the Boston Marathon bombing, to something like this on the right, a social media story of around 28 surrogates. And users already interact with pages like this every day. As we see on the left, there's a story on Wakelet put together by librarians about the 2021 Capitol attack. And Twitter creates moments that present surrogates linking to a topic of interest, like for astronaut Michael Collins. And social media stories apply visualizations that users already know how to understand. This is very valuable because this means that they don't require any additional training in order to be able to process the visualization. As we see in the upper left-hand corner, an individual surrogate summarizes a web resource. This particular surrogate consists of a striking image, a title, a description, and additional information. When we combine surrogates together into a story, we summarize a topic, as we do here with the one surrogate is about one article about the Boston Marathon bombing, but altogether we get a variety of them and we can understand the event. We want to extend this concept to web archive collections. We developed a 5-process storytelling model based on existing work on summarization and storytelling. A user can execute something to select exemplars. Remember, exemplars are documents that represent the collection well. And in our collections, the mementos are the documents. The user can generate story metadata. This involves extracting things like titles and who created the collection, but may also involve generating content like the top terms or entities in the collection. And a user could use the story metadata to select exemplars. Once we have exemplars, then we can generate document metadata for each exemplar. Document metadata consists of things like a title, a description, and other content that represents a document. Then we can visualize the story and distribute it. Now, Al Nomaini pioneered this work, combining web archive collections with Storify. But as we'll talk about later, Storify is now gone. Our 5-process storytelling model maps to our research questions. For selecting exemplars and generating story metadata, we ask what types of web archive collections exist and what are their structural features. Because if we understand the types of web archive collections and we understand their structural features, then we have some ideas on how to select exemplars. And this leads into what approaches work best for selecting exemplars from web archive collections. Once we have our exemplars, we can generate document metadata, which leads into research question number 3. What surrogates work best for understanding groups of mementos? Surrogates are visualizations of document metadata. So if we understand the surrogate, we get an idea for what document metadata we need to generate. And thus we get to research question number 4. What methods that automate the creation of surrogates produce results that best match humans' behavior? And then for visualizing and distributing the story, we'll cover some examples and use cases for our personas. Our Dark and Stormy archives tools serve as a reference implementation of our storytelling process. And Dark and Stormy archives gets its name from the writing prompt. It was a dark and stormy night, which has been popularized by this particular Snoopy cartoon. As we see here, we have all of our processes, selecting exemplars and generating story metadata, which we address with our research questions 1 and 2. And we have a reference implementation in the tool Hypercane. For generating document metadata, we address that with research questions 3 and 4, and the corresponding reference tool Memento Embed. And then for our storytelling processes of visualizing and distributing the story, we have examples and use cases that we'll discuss. And that is covered by our reference tool, Raintail. So now we can talk about background and related work. URIs identify resources. URIs are a superset of identifiers that contains things like URLs and URNs. We're most familiar with URLs because we'll type something like HTTPS and then a host name like example.com and maybe a path. And we'll put that into our address bar and then go visit a web page. We're going to use the term URI because it's more general. URIs identify resources. As we see on the right, For the resource Oaxaca Weather Report, the URI identifies that resource, but the resource may have different representations depending on the user's needs, such as it might need to appear in English or Spanish or Japanese, depending on the language that the user speaks. HTML is the file format we use for web resources. It contains links to other pages identified by URIs. And web archives apply crawlers to quickly visit pages and then follow these links to build collections. They save each page in the work file format. And as we see in the upper right, we have a diagram. The timeline at the top of the diagram represents the seed or original resource as it's changing in time. Think of this like, for example, a web page for a restaurant whose menu changes every day. We can make observations of that original resource at specific times, and these observations are mementos. In this example, we have a memento with a memento date time, which is when it was captured, of 4/24/2010 at 3:04. And then we have a separate one at 5/17/2010 at 10:43. Its memento date time, again, is when it was captured. And then we have a separate memento at 7/4/2010 at 7:18. Each of these mementos have its own URIs so we can find it. And we use the term URIM to denote a memento's URI. A time map gives us a listing of the mementos available for an original resource. As we see on the left, we have the Old Dominion computer science page as it is now. Honestly, I took this picture a few days ago, so it may not exactly look like this now. But that's the point. As we see on the upper right-hand corner, we have a time map. A time map gives us a listing of the URIMs and the memento date times for the mementos of this resource. So we can look at things like a memento from 1997 showing the same web page as it looked at that time, or a memento from 1999, around the time when I was getting my bachelor's degree in computer science, or a memento from 2009, when Justin Brunel was still a master's student. And others have tackled portions of the problem of summarizing web archives, but only Al Nomaini addressed all of the processes. Al Nomaini identified the characteristics of social media stories and archivic collections, and she determined that popular stories contain a median of 28 elements. So we're going to just reuse that result. Now our model maps to hers, but we expand on her visualize step. And we generalize her selection step. Al Nomaini's sieve diagram, as you see on the right, gives us one solution for storytelling. It involves excluding off-topic pages, excluding duplicate pages, excluding non-English language pages, and then dynamically slicing, clustering the collection, and selecting high-quality pages, and then ordering them. We will explore other methods of selecting exemplars. Al Nomaini extracted some story metadata, but she relied on Storify to create and distribute the resulting visualization. Her proof of concept generated some document metadata, but again, she relied on Storify to generate the rest. As we see in this diagram on the left, her proof of concept code is represented by the black rectangle. And that satisfied the first three processes that we have. But Storify also took care of the last three. So there's some overlap between the third process. She produced some document metadata. She relied on Storify to take care of the rest. And she generated many different stories based on the exemplars selected by her proof of concept code, such as the Boston Marathon bombing story that I was using in the introduction. Through her user study, she demonstrated that participants could tell the difference between her solution stories and randomly generated stories. This means that the participants in her user study could identify that her stories had some quality that were better than just randomly selecting exemplars. Also, participants could not tell the difference between her solution stories and those generated by human archivists. And this is also important because this means that her stories were at least as good in terms of quality in the participants' eyes as those stories generated by humans. Unfortunately, her solution is difficult to generalize. Her proof of concept focused on Archivit, and Adobe shut down the story platform in 2018. So let's move on to the next solution. We'll talk about selecting exemplars and generating story metadata. As collection users, what structural features can we view from outside? Now, we want to use structural features because it saves us from having to download the collection's content. And they give us different insight than can be provided by text analysis or metadata. So in this particular case, we're showing two structural features for this collection, the number of seeds and number of mementos. And what we can see for this particular collection is that it contains 486,000 mementos. And thus we know when we compare to that particular metric to another collection, that this collection is quite large. We can answer questions like, was the collection built from websites belonging to one domain or many? As we see in the middle, for this collection about the South Louisiana flood in 2016, it was built from many domains. But this collection on the right was built from one domain, controlled by the National Library of Medicine. There's nothing wrong with this. This is just different curation behavior. In this concept we call domain diversity. We can also answer were most of the web pages in the collection top-level pages or specific articles deeper in a website. In the middle, we have a collection that consists mostly of top-level pages. On the right, we have a collection that consists mostly of deeper links. And thus we've demonstrated path depth diversity, which is another structural feature. Growth curves provide us with some understanding of collection curation behavior. As we see on the left, we have a visualization with two lines. The green line indicates when seeds were added to the collection. And the x-axis is the time, the lifespan of the collection over time. And so what this tells us is that more than 30% of the seeds in the collection were added at the collection's creation for this particular collection. The red line gives us an idea of the temporality of the collection because it's when mementos were added to the collection. And thus we get ideas for where the collection is clustered in time. And that helps us develop solutions for selecting exemplars. And we discovered 4 semantic categories in archivic collections. We went ahead and reviewed 3,382 archivic collections. We found that self-archiving collections dominate archivit. These are organizations that are archiving themselves, like the University of Utah Web Archive created by the University of Utah. These make up 54.1% of collections. The next category is subject-based. These are collections that are centered on a subject that is not really ephemeral. There's no time bound on it. And these are collections like environmental justice collected by Tufts University. These make up 27.6% of collections. Then we get to time-bounded expected collections. These are collections that summarize events that we anticipate. Things like sporting events or elections. So for example, the 2008 Olympics that's collected by the University of North Carolina. And these make up 14.1% of collections. And then finally, we have time-bounded spontaneous collections. These are collections about an unexpected event. Unfortunately, there were some archivists who noticed that the event happened and started collecting content for posterity. Folks like the ones at Virginia Tech, who created this particular collection about the Tucson shootings. And these make up 4.2% of collections. Some of these were evaluated in Al Nomani's work. We can bridge the structural to the descriptive. Using the structural features that I mentioned in the beginning of this section, we can predict these with a random, we can predict the semantic categories that I just went over with a random forest classifier. And thus we can address research question 1. What types of web archive collections exist and what structural features do they have? We noted that there are 4 different types of web archive collections, and they have various structural features for understanding their domains, for understanding their growth over time with growth curves, and this gives us some ideas for selecting exemplars. So identifying off-topic mementos is key to choosing exemplar mementos. Remember that collections have a topic, and seeds are selected by the archivists to support that topic. But mementos are observations of those seeds over time. And so as we see in the upper left-hand corner, we have a page that existed, and then it was gone. Now we see a 404 page in its place. Well, the Web Archive dutifully created a memento of that 404 page. However, This 404 page does not support the topic of the collection. So what we want to do is identify it so that we do not consider it in future steps when selecting exemplars. We're not removing it from the collection. We're just identifying this memento as one that we shouldn't process further. On the lower left, we have an Amnesty International page, and unfortunately their account was suspended. And that account suspension page was captured as a memento. This memento of this account suspension page does not support the topic of the collection. So we identify it and do not consider it further. In the upper right, we have a page about Occupy Wall Street. And then it was hacked. Now, while the hacked page is interesting, this memento does not support the topic of the collection. As we see on the lower right, sometimes pages just move on from the topic and they're not actually on topic for the collection. Again, we want to identify, we don't want to remove these mementos from the collection. We're just identifying that they exist and making sure we do not consider them in the future for selecting exemplars. We reviewed a number of processes for measuring the differences between web pages. And we repeated it in experiments done by Al-Nomaini, and we evaluated more similarity metrics than she did. And we found that differences in word count had the best F1 score for identifying off-topic mementos. The simple metric of counting how many words exist in one memento and then comparing it to another in the same time map allows us to see that a particular memento is off-topic. But filtering off-topic mementos is just one step in a set of algorithmic primitives for selecting exemplars. We went through the literature and we've reviewed Al-Nomaini's algorithm and other algorithms for selecting exemplars and doing summarization. And we found the primitives of sample, cluster, score, filter, and order. And we can combine these together. So in this particular example, we take a web archive collection and we filter it to exclude off-topic mementos. And then we filter it to exclude near duplicate mementos. Because remember, mementos are observations of the same page at different points in time, and sometimes the page did not change. So we filter these near duplicates, and then we can randomly sample from the remainder. And thus, this is one method to select exemplars. But we're not limited to this, of course. Ordering allows us to create meaning from a list of mementos. We can order a set of mementos by their memento date time, when they were captured. And then we can systematically return every jth memento from this list. Every jth could be every 10th, every 5th, depending on the number desired by the user. So here's another method of selecting exemplars. Scoring gives us an idea of how well a memento meets the information needs represented by a function. So we can combine these together. We can take a web archive collection, and then we can insert a query into this process. A query like a word or sentence. And then we filter out all of the documents that do not contain that query. We can score the results by BM25, which is a function that quantifies how well a query matches a particular document. And then we can order the rest by descending score. And thus we combine filter, score, and order to create a simple search engine. And clustering based on a feature is our other primitive. This allows us to imbue subsets of mementos with meaning. All the mementos that are in the same cluster have some similarity to each other. And thus we can create these different clusters in the collection and get some ideas about aboutness for the collection. And if we combine these primitives together, we can reproduce Al-Nomaini's algorithm, which we'll now call DSA1. And these primitives allow us to create other algorithms for selecting exemplars that tell the story that the user desires. DSA2 focuses on clustering with k-means clustering in time so that we take into account the collection growth curves that exist for these collections. And then we can score mementos by how well they produce surrogate metadata. That's DSA2. DSA3 focuses on mementos that best match a collection's topic. DSA-4 focuses on finding the most novel mementos in a collection. So with this, we acknowledge that search engines are the de facto method of exploring collections. And if we consider them to be a baseline, then how retrievable are the exemplars produced by the DSA algorithms? So we loaded 8 different archivic collections into different instances of Solar Wayback, which is a state-of-the-art web archive search engine. And then we executed the 4 different DSA algorithms that I just went over to produce exemplars from these collections. We then generated queries with 4 different methods based on the content of the exemplars. So, for example, here's an exemplar on the left from a collection about the Virginia Tech massacre. This particular exemplar comes from the Washington Post. If we run the doc-to-query T5 method over this exemplar, we get a list of questions that a user would ask of a search engine that would return this document. We also extracted the top entities, which are places and names and things like that. We extracted the top entities to simulate queries from a user that was looking for information on this topic. We also generated a lexical signature from the exemplar. And lexical signatures are a method that people can use with general search engines to find the same topic or find the same document again. This simulates a user that vaguely remembers the document but can't remember its title and wants to find it again. And then we have the title of the document. We extract the title, and this simulates a user who is searching for this document specifically again. And as Klein established, titles are a good way with general search engines to find the exact same document again. We visualize the percentage of exemplars that were never retrieved by any query. So with these visualizations, these line graphs, each of them represents the exemplars that were produced by an algorithm, in this case, DSA-3. We also represent the retrievability based on the queries produced by a particular query method, in this case, doc-to-query T5. On the x-axis, we show the number of search results that a user would have to review before they find the exemplar. On the y-axis, we have the percentage of exemplars that have 0 retrievability. So in this particular visualization for DSA-3, using the doc-to-query T5 queries, at 10 search results, 57.82% of the exemplars were not retrieved that were produced by DSA-3. Now, 10 search results is the number of search results that most of us will give up on if we're trying to find something. But in order to simulate a user that was very, very diligent, we also evaluated 1,000 search results. And at 1,000 search results, 36% of the exemplars were still not retrieved. And for all query methods, the DSA algorithms exemplars have similar retrievability. If all pages are relevant, then DSA algorithms produce mementos with more novelty and than standard query methods can with a state-of-the-art web archive search engine. And remember, DSA-4 was supposed to surface novel mementos, and it met its goals with these results. So this helps us address research question number 2, which approaches work best for selecting exemplars from web archive collections. For finding off-topic mementos, we found differences in word count, a simple metric that we can use. We also created a list of algorithmic primitives, and we constructed different algorithms with them. And then we evaluated 4 of those algorithms against a state-of-the-art web archive search engine and standard query methods, and discovered that there's still mementos, there's still exemplars that were not retrievable. And we implemented these primitives as part of Hypercane. Hypercane was used to conduct the experiments in this section. With Hypercane, a user can select exemplars and generate story metadata. Now that we have our exemplars, we have our story metadata, we can generate document metadata. We evaluated 55 platforms in 2017 and found that existing social platforms do not reliably produce surrogates for mementos. As we see on the left, I inserted several different URIMs into this Twitter moment, and none of them produced a surrogate. We shouldn't see the URIM, we should see some representation of the document that it identifies. As we see in the middle, I inserted a URIM into Tumblr for this particular Tumblr post. It extracted the title, but did not produce the rest of the surrogate. And as we see in the upper right, with Facebook, I inserted a URIM into this Facebook comment. On the top, it produced a surrogate. Another URIM on the bottom did not. And if we cannot rely upon the service to generate a surrogate, we'll have to create our own, which then begs the question, which surrogate works best for understanding Web Archive collections? So we reused exemplars that archivists had selected from their own collections to create stories with different surrogates, like the Archivit-like surrogate, which just visualizes the mementos as they would appear in Archivit. And browser thumbnail surrogates, which are just screenshots of the same page in a browser. And we did this because browser thumbnail surrogates are popular, they're a popular surrogate type used by web archives. And social cards come from social media platforms like Facebook or Tumblr or Twitter. And these social cards were specifically designed to include information from web archives. SC/T combines social cards and thumbnails together. So by replacing the striking image in the social card with a thumbnail, we get a new surrogate type. SC+T places the social card to the left and the thumbnail to the right. So, because our thought was the more information, the better. And SC*T is interactive. When the user hovers over the striking image in the social card, a thumbnail for that particular page appears. This provides both types of surrogates in a much smaller space. We then presented stories with these surrogates to Mechanical Turk participants. We had 4 different stories, 4 different collections, 6 different surrogate types, 24 different story surrogate combinations, and we presented them to 120 Mechanical Turk participants. They were given 30 seconds to view each story. And then we asked them which of the following come from the same collection. They were asked a question. They were shown 6 surrogates of the same type as the story that they just viewed. And they were asked to choose the 2 that they thought came from the same collection. And this is very similar to the sentence verification task used in reading comprehension studies. Now, social cards probably outperform the Archivit surrogate in terms of participants' correct answers at p equals 0.0569. But also interesting is that social cards produce less interaction when participants are viewing the story. We measured the clicks and hovers that participants used when interacting with the web page. And for browser thumbnails alone, most of the participants clicked on the link to view the content behind it rather than just viewing the browser thumbnail. So to address research question number 3, which surrogates work best for understanding groups of mementos? Social cards. Social cards are generated based on the HTML metadata that authors provide. Authors can edit the HTML of their web page and insert a metadata field like OG:title. And then they supply a value. This value will then be used by Facebook as the title for the card whenever someone shares that particular page on Facebook. OG stands for Open Graph Protocol, which is Facebook's standard for doing this sort of thing. Twitter also has a similar standard, thus there's Twitter title. OG description is how a user specifies in their web page what description they want to appear on Facebook when someone shares their web page. And the same thing with Twitter description on Twitter. An OG image for supplying a URL to the striking image. So what do we do if this metadata does not exist? Well, as we saw before, Twitter just gives up and doesn't generate a card. You just see a list of URLs. Facebook tries to parse the title and produces a card with just a title, but it doesn't always do that, as we saw earlier. So we analyzed almost 300,000 news articles captured by the Internet Archive from 1998 to 2016, and we found different rates of metadata adoption. We took each metadata field in each of these web pages, and we put them into different groups based on their standard or use case. And we found that once card metadata was introduced in 2010, as either Open Graph Protocol, which is what Facebook uses, or Twitter cards, it experienced meteoric adoption by page authors. So clearly page authors want to produce good cards for their pages. And before 2010, these standards did not exist. Remember, mementos are captures of web pages at different points in time. And so prior to 2010, this metadata did not exist in these web pages. And if we want to tell stories with web pages prior to 2010, we have to generate our own card metadata. So by applying author behavior, we can generate descriptions. We analyze the descriptions that were produced by authors in the pages that did have metadata. And this tells us that authors tend to write card descriptions that have 268 characters, 52 words, or 2 sentences. And this is useful because we can apply an automatic text summarization algorithm to produce the description portion of the card. But it needs to know how long the description needs to be. And so if no metadata exists, we can select a striking image from the images available in the document. Here we have a screenshot of a Wall Street Journal article titled "Choosing the Right Healthcare Plan." I've outlined all of the images in the article in red. Which one is the striking one chosen by the author? How would a machine know that? How do we know this? Our generic image selection approach has 3 steps. 1, score each image in the document by some approach. Then sort the list of images by descending score, and then choose the image at the beginning of the list. This is the highest scoring image based on the approach. As I show in the middle, we sorted all the images by color count. As I show on the right, we sorted all the images based on the probability produced by a classifier that this was the image chosen by the author. And as you see, we get different results. And we visualized how well different approaches performed at choosing a striking image that was perceptually the same as the author's. As we see on the x-axis, as we move to the right, we're accepting more images as perceptually equal to the one selected by the approach. On the y-axis, higher scores indicate more accurate answers from this particular approach. In this case, this approach was linear discriminant analysis. So the best approach starts in the upper left-hand corner with the 2 lines. And we found that random forest performed best with base image features quickly calculated via standard image libraries. Base image features like byte size, size in pixels, number of colors, aspect ratio, and so on. So to address research question 4, what methods that automate the creation of surrogates produce results that best match humans' behavior? We found that authors really want to produce cards for their pages. We determined how long the descriptions need to be, and we found that random forest can help us choose the same striking image as the author. We implemented these results as part of Memento Embed. Memento Embed is an archive-aware surrogate service. This means it can produce surrogates that contain information from the archive. As we see with the cards in the top middle, we can also produce browser thumbnails, which are just screenshots of how the page looks in the browser. Image reels, which are the top images in the document represented as an animated GIF. And then finally, word clouds. Memento Embed also has an extensive API for generating document metadata. So now that we've selected our exemplars, generated our story metadata, generated our document metadata, we can visualize and distribute the story. Because Storify was gone, we created Raintail to visualize and distribute stories. Storify was nice. It had an API that allowed us to customize how our stories looked. This functionality was gone, so we created a platform-agnostic storytelling tool in Raintail. Raintail takes in a template and a list of URIMs, and then generates a file or social media post based on that input, based on the user's needs. Remember, Elbert wants to promote his collections for others, so he uses the DSA toolkit to do so. Today, he's promoting a collection about COVID-19. He moves from this, a collection of more than 23,000 mementos, feeds it through Hyperking, Memento Embed, and Raintail, and then produces this on the right, a sample of 36 mementos visualized as social cards, phrases, and images. On the left, we have facets in a search engine and seeds that were painstakingly selected by archivists. On the right, we have people in masks. We have pictures of the virus. We have maps showing the virus spreading across the world. We have headlines and dates and sources and names. and links back to the original collection so that once a user understands this story, they can explore the collection further for their needs. Albert applies all of the processes of our storytelling model. For selecting exemplars and generating story metadata, he uses Hypercane, and Hypercane produces a file that he can then feed into Raintail. And with his template, he can ask Raintail to create a story, but Raintail then consults Memento Embed for generating document metadata, and then Raintail visualizes the story, which is then distributed via GitHub pages. Remember, Natasha needs to compare collections to each other. Today, she's reviewing collections about shootings at places like Virginia Tech or El Paso or Norway. With these stories, she can see pictures of victims and perpetrators, titles, headlines, dates, names, places, and she has links back to the original collection so she can explore it further. Ling inherited a collection and needs to know what it contains. She uses a different template. She can move from this, as we see, a collection with 88,000 mementos with no metadata whatsoever, feeds it through Hypercane, Memento Embed, and Raintail, and then produces this, 50 exemplars with structural features, metadata analysis, growth curves, and other statistics that she needs as an archivist to understand this collection so she can make decisions about it. Rustam wants to see how a page changed over time. He uses Hypercane to identify pages, and then he filters based on a specific seed. Then the rest of the process is the same, but he distributes his story on his personal website so he can collaborate with other researchers. Rustam chooses one of Raintail's default templates because he's using the DSA toolkit for exploration. Olayinka wants to see what different news sources said on the same day in different years. And with our Sherry process, which I'll cover on the next slide, she can compare different years to each other, or even different days. As we see on August 8th in 2018, the US news was covering upcoming US elections. In the middle, in 2019, on the same date, the US was concerned about the mass shootings in El Paso and Dayton. On the right, on the same date in 2020, all we could talk about was COVID-19. Olayinka can look through the stories produced by our Sherry process to perform her comparisons. The difference with the Sherry process is StoryGraph, a tool that's not part of the DSA toolkit, but that specializes in analyzing news. StoryGraph is used to select exemplars. And then the rest of the process flows as we saw before. So now we get to contributions and conclusion. We presented a model for storytelling with web archives. This involves selecting exemplars, generating story metadata, generating document metadata, visualizing and distributing the stories. We established a vocabulary for different types and structural features of collections. We found there are 4 different types of collections and different structural features. We presented this result at IPRES in 2018. We found that differences in word count is a fast, effective intra-time map method to identify off-topic mementos. And we presented this in a separate paper at IPRES in 2018. We devised a set of primitives for intelligently selecting exemplars from web archive collections with sample, cluster, score, filter, and order. And we created different algorithms with these primitives. Hypercane implements our primitives for selecting exemplars, and we will present Hypercane later this year at ACM IEEE JCDL 2021. Hypercane will also appear in the ACM SIGWeb newsletter later this year in 2021. We created 4 different algorithms from these primitives, and we found that they produce exemplars that have low retrievability with a state-of-the-art web search engine or web archive search engine. And query methods, standard query methods. We also determined that our DSA-4 algorithm did surface the novel exemplars better than the others, as we expected. And our user study provides engineers with support for choosing social cards over other surrogate types, as we presented at ACM CIKM in 2019. We established methods for generating the metadata for social cards if it doesn't exist, and we presented this early this year at ACM Web Science in 2021. We explored the reasons for metadata adoption. Many efforts have been made to encourage metadata adoption by web page authors. And once social card metadata became available, its use skyrocketed. And we'll present this later this year at ACM IEEE JCDL 2021. We released Memento Embed and Raintail as reference implementations for visualizing and distributing stories. And we presented them at Web Archiving and Digital Libraries in 2020. We also went over the Sherry process, which gives someone a story conveying the biggest news story of the day. And we also presented that at Web Archiving and Digital Libraries 2020. And I'm eager to apply this expertise at Los Alamos National Laboratory's Information Sciences Division, CCS3. As we see on the right, I have my own story with the different places that I've worked. And I produced this with Raintail. Using our model and the lessons from these research questions, we have implemented tools to tell stories that summarize Web Archive collections. Please, I encourage you to read the dissertation for use cases, for more example stories, details on our experiments, details on the tools, examples with web archives other than Archivit, including those from the National Library of Australia, where we have a generous grant from the IAPC to pilot this process so that they can produce their own stories from their collections. And we also have in the dissertation a sample of future work ideas for better summary evaluation, augmenting collections with live web metadata, producing stories with cards that don't just summarize documents, but entities or topics, summarizing scholarly output, summarizing project status, producing scatter-gather interfaces with this implementation, and potentially solving corporate intranet search issues. So I encourage you to come to the Dark and Stormy Archives webpage, oduwsdl.github.io/DSA. Review our research. Take a look at the tools, the software. Look at our presentations and ask yourself a question. What story will you tell with Web Archives? Thank you for your time.
All right, thank you, Sean.
Appreciate it.
Next step, we will take questions from the audience. Who wants to go first? So, Sood, I know you're there. Surely you have a question.
All right. So, I mean, it was fantastic, Sean. Nicely presented.
Thank you.
Yeah. When you were talking about scoring images on a page, you considered the size or dimension of the image as well, right?
Yes. Let me go ahead and go back to. Sorry, I'm having a hard time with PowerPoint today. Let me go back to that slide, and I will show you. We had different features that we used, and we were trying to find a method that would produce a surrogate fast, and that's why we chose some of the approaches that we did.
Right.
We didn't want people to be waiting for a surrogate to generate. And so here we have just some of the results, because we reported these. We went ahead and looked at other results as well, and none of them performed as well as these. And that's saying something for comparing some of these, because as you can see, the lines on the left appear pretty low in some cases. But as you see on the right, we had base image features. This is the name that we gave them because there's something that you could use image magic or PIL, Python image library to produce. And these things like the number of colors, the aspect ratio, size in pixels. But the other thing that we were concerned about was we wanted something that was agnostic between different image formats, because some image formats have the ability to, or they have different features and different metadata and other things than others. Like with JPEG, you have EXIF data, but other image formats may not have that. So we wanted something that was standard across these different image formats, at least the ones that were shared on the web.
So, like, I mean, the perceptual aspect of it, right?
Oh, well, okay, so that's a different thing. Yeah, you're right. I didn't explain that, and I apologize. The folks at ACM Web Science got to see more of this. When we did the evaluation, and maybe I should just go back to this slide, you see that on the x-axis, it says image magic p-hash distance. And what p-hash does is it gives you a similarity metric that measures the similarity between two images. And unfortunately, this is an open area. For those of you looking for a topic for your dissertation, trying to compare two images to determine how similar they are is something that we've solved pieces of, but really haven't solved definitively. But what p-hash tries to do is determine whether or not a cropped image is the same as the larger version or resized image. Sometimes it's good at images that are slightly different colors, like sometimes articles want to do a black and white version of a color image. p-hash tries to do that sort of thing, but it's not great based on what we had reviewed. So we looked at different methods to evaluate whether or not the approach that we were evaluating, like in this case, linear discriminant analysis, we're looking at different methods to try to figure out if it produced an image that was good enough compared to the same one that the author had selected. And in that particular case, we found that image metrics like SSIM did not do a very good job. The p-hash that's implemented by a group of people in the image hash Python library, it does an okay job. But it turns out that Image Magic's p-hash implementation is better out of all those that we tried. So that's why it says this on the x-axis. And so essentially, as you go from 0 to 1, you're considering more images to be equivalent. And at 1, all images are equivalent in p-hash. So that's basically what this visualization is supposed to show. Every approach that we try is going to get a perfect score at a p-hash distance of 1, because that's every image is considered to be equivalent to each other. Did I over answer your question?
No. That was an interesting insight indeed. So what I was getting at is, I think a couple of slides before, there was where you have those multiple images kind of sorted by different attributes, and I was thinking, if you have image sprites, that will be perhaps larger in dimension, as well as sometimes color variation will be high as well. For example, you have an image CSS sprite of, say, flags of all the countries, and you are using just one tiny section of it. So on the view side of it, when it is used on the page, only a small rectangle is kind of utilized, but the image that is downloaded is a big image. It's just that those small pieces are used in many different places. And how will this algorithm react to situations like that?
Oh, that's true. So you're talking about the image as presented on the page, the size that it is in, per the HTML. That is a good area for future work. One of the problems that I had, I mean, we considered that, but we didn't get a chance to actually evaluate that, because it would require rendering all of these pages.
Right.
And I know you're like, well, wait a minute, you don't need a browser. You just have to process the CSS. Well, that's part of rendering. It turns out, at least based off of the work that I did and the libraries I found, rendering the CSS for a web page takes as long as rendering the individual page. And we just, honestly, that would be a great idea for future work, to see if someone could speed that up. So I agree with you. That would be a good way to evaluate it. There's a newspaper 3K. Oh, no, sorry, not newspaper 3K. There is a image evaluation or image selection process that was done by Cohen Kern years ago. And what they did was they did a combination of processing the DOM with analyzing the images in terms of size and aspect ratio to figure out what the striking image was. And the problem is that well, this particular study wasn't just evaluating web pages. It wasn't just evaluating news articles. We're also evaluating scholarly publications as well. And so we're, yeah, I didn't mention that because it didn't have anything to do with web archives, so it didn't make it into the dissertation. So that also informed some of the features that we selected and the methods that we chose. Because we wanted to see if the same method that would work for news articles would also work with like an article from PLOS One. And we found out with that paper, no, it doesn't. For news articles, we can do really well with random forest here and just these features. But with PLOS One, for example, we would have to process the headings and other things as well in the document. But see, web news articles don't have that kind of structure that you get from scholarly publications. So.
All right, Sean, next we have a question from Matt. He put it in the chat and said he doesn't have audio capability where he's at.
I'm sorry to hear that, Matt. Hi, Matt. Okay, so let's see here.
I can read it to you if you can't find it. I don't.
I think I found it. What sort of surrogate is generated for really old web pages before images were so prevalent on the web, but are nonetheless interesting web pages? Were any of said web pages used in the evaluation, since we want to apply the thumbnail generation algorithm to pre-open graph pages? Okay, so that's a good question. When we did the evaluation here, we only used web pages that had ground truth. So in this particular case, this part of the evaluation was only done on pages after 2010, unfortunately, because we had no ground truth to work with. But if we're going to produce a surrogate for a page that predates that, yeah, we would use random forest to choose the striking image. But if there's no images on the page, then what Memento Embed does is it just uses a default, which is not very pretty. I don't have an example of it here, but it's just a globe to try to fill that space and let you know that it tried to produce an image. Did that answer your question, Matt? Awesome. Okay.
He said yes. All right. So I think Alexander was next in line. Alexander, you want to ask?
Sure. Thank you very much, Sean. Your presentation was excellent.
Thank you.
I think it's a model for what PhD presentation should look like.
Oh, that's kind.
I
did copy some of your presentation.
Thank you. I just want to know that because you've solved so many different problems here, whether it's identifying off-topic mementos, selecting exemplars, determining what surrogate works best. So all these various problems, from all these problems, which one was the most challenging? And then similar to that, what would you say is the most significant contribution of this? Because there's a lot of contribution here. So what would you say was the toughest problem to solve, and also the most significant contribution you've made?
It's kind of hard for me to answer, because when I started, first thing that I was working on was categorizing the collections. And at that particular time, I was still learning how to become a researcher. So that seemed really hard at the time. But that was just going through and manually doing the hard work of looking at collections and figuring out which category they would fit in. And then, of course, trying to figure out what structural features made sense was another thing that was difficult. But in retrospect, it wasn't that hard because they were there. The structural features existed. It was something I could, if I just analyzed the collections enough, I would figure this out. Again, that was just looking at it. And then, of course, we fed the structural features into Weka to try different machine learning techniques to try to predict the semantic category. And in retrospect, that I'm not saying that wasn't significant, because there are people who've cited that paper. They're very happy with what we did there. But I wouldn't say that was as difficult as trying to figure out how to measure the image selection. I think the image selection is very difficult. And a lot of people have been trying to do the image selection, but nobody's done it with the actual author ground truth. So I guess I would go with that. However, if you ask me again after I think about it for a few minutes, I'll probably come up with something else. Some of the other things that I've done contribution-wise involve this was presentation of tools to help other people. The Sherry process I love. It's wonderful. In fact, I'm looking forward to making it happen again with the help of the CS department. Some of these, let's see here. I really liked what we did with exploring the reasons for metadata adoption, but that was more of an analysis. Whereas this actually trying to find which image the author chose was very, very hard, and it was difficult to find something that was novel because there was existing work. So that I would still come back to this, even as I look through these things. Well, and okay, now wait a minute. Now that I'm thinking about it, user studies, on the other hand, are always difficult, as Dr. J. Ratna could tell you. Yeah, trying to figure out how to evaluate users. This was hard. Okay, this was very difficult. So I would go with this, just because there's a human element involved that makes users it makes participants unpredictable. And then trying to figure out their motivations on Mechanical Turk and ask the questions the appropriate way, that was difficult. And I might argue more expensive than I wanted it to be.
Do you have a blog post that summarizes what you learned from conducting those difficult user studies?
I do. I can share it in the, I actually don't have that up at the moment, but I can go ahead and share that in the chat. I wrote a blog post about all the analysis done for using Mechanical Turk to do user studies, and it also brings up some work by Diane Kelly for how to conduct user studies, which I encourage you, if anybody in the audience is going to do a user study, there's a book, well, it's actually a really long paper by her. Read that first and then figure out what you're going to do, because Mechanical Turk is just a place where you can encounter participants for your studies. So I'll post that in a moment. Yeah, no problem. Thank you.
All right, next, I think Sood had another question.
Okay. Any recommendations on injecting or retiring OG metadata in Memento replays so that they are shared on social media? Good cards. All right, Saud, you got me.
I meant rewriting. So let me clarify that. Like, I mean, yeah. I mean, your work kind of illustrated some of those things. When you post like a URM in Twitter or something, you don't really see anything exciting. So the underlying page might have open graph tags and there, like descriptions and images and all those things, right? And sometimes they don't have, but if you are rewriting the page, then you can figure some of those things out. And as you said, some of the items need to be replaced so that it doesn't point to archives icon. Or when you are creating these cards outside using, say, Memento embed or something like that, you can come up with like as much metadata as you want. What can we do to kind of integrate this whole thing in our replay system directly, so that when the pages are replayed, necessary rewrites are done, so that when someone pastes these mementos on social media, they see interesting or relevant graphs there, and cards there. And that also includes, like, sometimes, do we want to replace in place? Like if the open graph tags are present in the page, do we want to replace in place, or add another one underneath that or above that, or how some of these platforms prioritize those things? So if you have like duplicates, which one is kind of takes precedence?
So to answer, okay, I'm going to try to answer all of your questions, and you'll have to let me know which one I missed out on, because there's a lot of facets to this, and this is one of those things where you start peeling back on it and you see just how complex it is. Okay, so let me show you an example first. So for Sean's story here, you'll see that I intentionally chose different mementos from different web archives. We have on the top for information sciences, which is where I'm going to go work, and in that card under where it says 2021, you see it? Mm-hmm. It says archived by archive.is. And you'll see that the striking image to the left looks an awful lot like a browser thumbnail. And that's because it is. And that's because archive.is overwrites the Open Graph tags that exist for that page. So one of the things that Memento Embed does is it looks for the Open Graph or the Twitter tags first before trying to generate the metadata on its own. So archive.is, on the other hand, tries to generate these tags for the Memento. And I have mixed feelings about that. On the one hand, you always get a striking image, which is great. But on the other hand, it's not representing what was there at the time. And that's one of the reasons why when we did our study analyzing the metadata use, we looked at mementos that were being served by the Internet Archive, because you guys actually serve up what we call the raw mementos. We're able to get to those and find the actual Open Graph tags that existed at the time of capture, which is the sort of thing that we needed.
Right.
Whereas we wouldn't have been able to do this study with archive.is. So if you're going to add this functionality at the Internet Archive, which I'd be happy with, just make sure that someone can still get back to the raw content so we can do studies like we were doing. It's possible that if there's many different ways of selecting the image. I mean, we chose to select the images from the page itself. Others, especially scholarly publishers, they don't do striking images in the way that I mean. Their striking images that they choose are their own publisher logo, which doesn't really summarize the content and kind of makes me a little annoyed, because they're doing the author a disservice by just giving the publisher logo instead of an interesting visualization from the paper. PLOS One, on the other hand, asks authors to choose a striking image for their paper. And I think that's the way that these publishers should go. I mean, there are visualization journals, or journals in the visualization field, and what they do is when you submit your paper and it gets accepted, they want to know what striking image you're going to use because they put it inside the journal as part of the magazine. But that's just one particular field, and I'd like to see more scholar publishers do that. I know I kind of went off on a tangent.
I'll jump in. This Herbert sent a question that's sort of related to, at the same time that you're rewriting for Open Graph stuff, you could also rewrite. He's pointing to some work from the L3S group about injecting semantic web tags to essentially facilitate question answering, right? Because once you've opened the door for rewriting, you can stick all kinds of stuff in there. So.
Oh, that is so true. The only thing that I ask is that we still have access to the original content that was captured. And I've talked to you, Saud, and I also talked to Ilya about different methods that we might try for that. Herbert and I had long conversations. We wrote 2 blog posts about presenting the original content that was captured, because it's so valuable for research like what we were doing with the metadata. We wouldn't have been able to do this without the Internet Archive's holdings and without that functionality that you all provide. So we really appreciate that.
If you're not going away anywhere anytime soon.
Okay.
So,
yeah.
Last call for questions from the audience. Anyone else? All right. If not, we'll move on to questions from the committee. And who on the committee wants to go first?
I'll start with the low-balling one. Why the exclusion of non-English documents?
Okay, so that was specific to Alnomani's implementation, and we did not do that with DSA 2, 3, or 4. I believe she was doing that largely because she didn't want to have to alter the settings for tools like NLTK and other natural language processing tools for different languages, especially when it can be difficult to try to determine what language a document actually is in. That there's a whole body of research on trying to predict the language that a document's written in, and we've got varying degrees of success, and it even gets worse when you're processing a document that's multilingual. So I think that's the reason she did that.
So
pretty sure I
was
could
there any
find-
reason, but you did follow the same pattern. So you did follow the same, let's say, what's the word? The same suggestion, given the same restrictions. So am I correct?
True, true. And honestly, we have not really tackled that problem effectively, I think. That is an excellent idea for future work, I think. So you're
Well,
talking about like
I'll-
what we did here.
So
Oh,
I'll
go
point
ahead.
out the gold standard data that Yasmin created in her dissertation was English language.
That's true.
That again?
And
So in Yasmin's dissertation, however many years ago now, she created some gold standard data where we got archivists to go through and for each collection say, I think these are the 28, 30, whatever, most exemplar mementos. And those were in English language, I believe. And that's what we were comparing the original work to, how well the algorithms match the human selected gold standard. But the other stuff, like all the structural features, are going to be language independent.
yeah, things like the memento date times, when things were captured, how things cluster in the collection based off of, well, yeah, I mean, I guess that's a big one is memento date times, but you can also cluster based off of the original resources or the domains in the collection. There's different things you can do that have nothing to do with the language.
Let me do a follow-on with what you mentioned that Jasmine's work was difficult to generalize. Why?
It was very, very heavily dependent on Storify. She
Yeah, but the Storify is an implementation. It's not necessarily the design or the algorithm that goes behind the implementation.
true, but she scored mementos based on how well they would appear as surrogates on Storify, instead of evaluating how well they would appear in general. She didn't go into analyzing metadata like Open Graph Protocol and other stuff like that. So that's where I think it was difficult to generalize.
Please itemize for me the elements that you find difficult to generalize. So first, the metadata. That's an element that is difficult. She didn't have the metadata, so that's difficult to generalize. What else was
Sure.
difficult to generalize?
Let's see here. The other thing that she had was her visualization was very specific. I mean, she didn't have to think about how to visualize the story or distribute it. And also, it's very, very much fixed to Storify. Let's see here, for selecting exemplars, she touched on ideas for different types of stories, and she defined different types of stories in her dissertation, but she didn't really talk about one would go about creating different algorithms to create these other stories. So things like, I don't talk about it here, but in my dissertation, I echo her fixed page sliding time story, which is something that that Rustum is looking for. And with the implementation that I've got and with the primitives in the algorithms that I've created, we can do that. Whereas with hers, she never really talked about it again after bringing it up as a possibility. So that's another example of things that were difficult to generalize. So we talked about distributing and visualizing. We talked about the document metadata. For selecting exemplars, you did point out a good point with English language work here. I think that that with our set of primitives, one could construct an algorithm that that works for collections that are not English language, and so that's another thing that I thought was difficult to generalize. You don't necessarily, when creating an algorithm for a collection, have to slice it in time. Maybe you don't care. It depends on what the user's needs are. And I think the thing that I came to realize after talking to archivists and librarians and other folks was that there's a lot of different needs out there, and there's a lot of different stories that we can tell. So that's why I think that this is not the, one size fits all algorithm for selecting exemplars and generating these stories.
Okay.
Thanks. That's a good question.
Besides Jasmine's, what other work exists that attempts to do the same?
So that was something I was looking for early on, and I might have a backup slide hopefully. Okay, I'll just show you all my backup slides. In case anybody's interested, these are surrogates too. If anyone remembers, these are library cards. These are another way to visualize a document so that we understand what it contains. Sorry, I just had to, I really wanted that to be in the presentation and couldn't find a place to fit it in. I have something here on other people's work. Man, I'm just gonna go through everybody's slides. Generate story metadata. Here. Okay, so there are other folks who have tried to summarize Web Archive collections through analysis of different statistics. So we have things like Archive Spark. I'll just make this bigger. As you see on the left, this is a screenshot of Archive Spark. And Archive Spark is an amazing tool created by Holtzman, and it allows you to filter collections and really get down and measure domain names and all kinds of other stuff. The problem is that, like I say in the title of the slide, it requires that the user have access to the works that make up the collection. The works are the actual files where the data is stored. And this means that archivists can create these analyses of these collections, or someone who knows an archivist and can ask them, hey, can I get access to your data? But a general user can't do that. So that was one of the critiques I had of these particular techniques for analyzing collections. Now this means that folks like, Elbert or Ling here, which, my examples of archivists, can run Archives Unleashed on their collection and generate interesting mix and other things for their users. But a user can't do it for themselves. So the point is that I'm not just interested in making sure that archivists can present their collections. I want them to be able to do it, but I also want all of us to be able to do this analysis and summarization as well. And so that's one critique of somebody who tried to do something similar to try to understand collections. You also see that they're not doing storytelling. They're just extracting data and visualizing it, much like we do in standard research. And that's not going to be something that's approachable for most end users. Most end users, they would have to learn, okay, so on the right here, we see Archives Unleashed Cloud has this beautiful graph of the hyperlinks and how the different mementos link to each other and everything. And that's great. I recognize it as a graph. I think it's pretty. The colors may indicate something to me, but I have to learn how to consume that. Whereas someone on the web who is not familiar with some of these visualizations, they understand surrogates and cards. I mean, they see them in places like search engines, and they see them in stories and other places. So that's another difference that we have. Did that answer your question?
Yes, one last question from me.
Sure.
As you have mentioned the limitations of these works, what is the limitation of yours?
That is an excellent question. Okay, so I actually built in some limitations. One of them is that I think these are wonderful tools, and my work does not process works. My work is targeted at people that want to summarize Web Archive collections from the outside. So that's one limitation. Now, we could easily put works into the mix and figure out how to convert works into URIMs and all that other stuff. It's not that I didn't want to do that. In fact, I thought about it at one point, but I realized these tools have a space. So that's one limitation. The other is that the storytelling model that I'm using is very, very much specific to documents. And as I talk about in the future work of the dissertation, there's other types of surrogates and other types of visualizations that we can use that convey meaning that people are already familiar with. I don't have a good example here, but things like if you search for somebody famous on Google, you'll see on the right-hand side there is a card that shows up, and it shows the person's name and maybe has links to their Wikipedia article, talks to other things that are relevant to that person. If they're an athlete, it might be statistics about them. If they're an academic person, it will list the people that they frequently collaborate with. And so that is another possible way to convey meaning and help people understand collections. And we just don't do that. We don't currently do that with Raintail and Memento Embed can't do that. And Hypercane doesn't understand how to produce anything like that. And I talk about the tools because they are the reference implementations. Selecting exemplars might help you get to maybe these entity cards, but it's not the way that you're going to use. It's not the way that you're going to use to understand. I'm sorry, I got distracted by the question in the chat. Hypercane, or our method for our algorithmic primitives, could help you produce documents that summarize the collection, but they won't really help you get to the entities that you need for a card like that, is what I'm getting at. So we'd have to come up with some other method to produce a story like that. So that's assuming that we're still trying to fit into the mold of producing a visualization that users understand how to consume because it's something that they've seen before. Now, if you want to go with other visualizations that exist out there, yeah, there's all kinds of limitations on what the different tools can do.
Thanks.
Yeah, I'm sorry, I got lost there. I saw giving Zoom presentations is a little distracting. So sorry about that. Actually, let me answer Matt's point here. It's Hypercane that does the replay. We had an early version of it in a library that I created called Archive It Toolkit. Sorry, Matt had asked, somebody was working on generating works from actually looking at the collection from the outside. And this is different. I implemented this in Hypercane so that we could do the study. Yep, PowerPoint is becoming a problem again. Oh, sorry. So that we could do the search engine study that I talked about earlier. I needed to, where is it? Yeah, for Solar Wayback. In order to insert the collections into Solar Wayback to do this study, Solar Wayback is another tool that only understands works. So in order to conduct this study, I had to synthesize works from the collection as an outside user. And you might ask, well, why didn't you just ask the archivists for their collections? Well, I didn't know them, and I also didn't I didn't have a way to ask them per se. One of the problems with Archive It is that you can see the organization that has a collection, but it doesn't necessarily give you information on who manages it. So Hypercane is the tool that allows you to synthesize works from the replayed web pages, replayed archived web pages. Sorry, I interrupted the flow there.
Fine question on what you just said about the timestamps. Can you see that?
Oh yeah, thanks, Olga. Okay, yes. The nice thing about the works that are synthesized by Hypercane, and this is an experimental feature, by the way. Okay, it was good enough for our experiment here with Solar Wayback, but if you're going to use it, let us know what problems you encounter. What it does is it reads the memento date time from the memento date time header and then uses that as the work date in the work when it sizes the work. It takes the URI-R, which is a term I did not define. It takes the original resources URI and uses that as, I think it's, I can never remember this, the work URL something, and it uses that in the work as the URL that was recorded, rather than using the URIM. And it stores the URIM in a separate field that Ilya Kremer had suggested. So it's trying to, as best it can, synthesize something that resembles the original work based on the information that we can see from the outside. I haven't advertised that capability a whole lot because it's still kind of experimental, but like I said, it was good enough for the SOLAC experiment.
All right. So if Dr. Padilla is done with his questions, we can always come back. We can move to somebody else.
I can be the next.
Okay.
So first question is to echo Dr. Padilla's question. I think I mentioned this before when you were doing some presentations before. So how do you compare your work with the work in NewsLens? So the NewsLens is a project was initiated by UC Berkeley, Marty Hurst. She also had a website which summarizes this news articles in chronological order and aggregate them. So I wonder if you have if you are aware of this project, and if you are, how do you compare your work with their work?
Honestly, I am not aware of the project, and I apologize. Yeah, I don't know because I'm not familiar with it. I know that Alexander Nawala and I got together for news specifically, and I applied his StoryGraph tool, which analyzes news, and just took its output. So I know he does something based off of clustering on, and of course he's not here to talk about it because he just stepped out, but it does something based on clustering of entities. And I'm not sure if the tool you're talking about does something similar to try to analyze the news. So what is the name of the tool again? You said NewsLens?
Yes.
Oh man.
NEWSLENS.
Okay. NEWSLENS?
Yes. It's
NewsLens.
newslens.berkeley.edu.
Oh, wait. Okay, wait. I think I do remember this now. Okay, well, let me bring it up so everybody can see. So this is NewsLens. And this, yeah, I have to confess, I vaguely remember this now, and I apologize. I guess I did not look at this. Well, the first thing is that this is based off the now, isn't it? So this is something that is based off what's currently occurring. And if I can show you, we have.
Well, I'm not sure if they use archive data or they have their own crawlers, but I just know that it seems they're trying to generate a similar effect as your project.
They are, and this might be very helpful for collaboration. TechCrunch and all this other stuff here.
Yeah,
this is really cool. I like this. What we did was, and I'm waiting for it to come up here. It's a little slow. I'll just have to pick something. These are articles that were chosen by StoryGraph.
Zoom in on that.
These represent, what's that?
Zoom in on that. It's really small.
Oh, I'm sorry. Okay. So these are articles. Do you guys see it okay?
Yes.
Okay, good. Yeah, this is where I should be looking at the other Zoom to make sure. Anyway, these are articles from May 28th, okay, 2021, which was the last time, unfortunately, this ran because there are some technical issues at the CS department right now. And these articles were chosen as representing the biggest news story of the day by StoryGraph. And so what our process does is it accepts that input and then preserves those articles as mementos so that they're available in the future. Now, this was run the day after this particular event happened. However, the neat thing about StoryGraph is that we can extract data from any date up to the point in which it was brought online. So we can produce one of these stories for the biggest news article of, I think, back to 2018 or maybe, sorry, 2017 in August. That's something we can do that this news lens doesn't appear like it does, because it's talking about current events.
Yeah, right.
This is very, very similar to another set of tools. And remember, I said I went over 55 tools. I didn't want to go over all 55 of the presentation. I wouldn't have enough time.
No, that's fine.
Yeah, but there were other tools that focused on this sort of thing. This is better, I would argue, but similar to something like what was it, Paperly, I think, was a way that you could create a story about current events, but it was all customized to what you wanted. And that's a different dimension to introduce to these stories as well. But yeah, Newslands looks really cool. In fact, I might want to bookmark this. This is nice.
Okay, good.
So related to that, Sean, if you need any introduction to Marty, I can contact her and let her know about you. If you're thinking about the collaborations in the future.
Well, that would be great. Yeah, I mean, yeah. I'm going to go work for CCS3, but I'm definitely looking for people to work with.
Yep.
Okay, good. So the next question is that when you are selecting the web pages, especially when you are merging the, web pages are telling similar stories, so what is the representation for the article? Like, how do you model the article so you know that two web pages are talking about the same story?
Oh, I see what you're saying. Okay. So if you have two, so to eliminate near duplicates, we use SimHash, which I realize is not quite the question you're asking.
Yes. But you are SimHashing the whole article or just the metadata?
Oh, the whole article.
The whole article. Okay.
Yeah.
So SimHash, it takes the literal, but it does not take the semantic into consideration. So there has been many language models developed which encode the semantics of a whole document into a vector, and it seems have been widely used, widely applied in information retrieval and document classification. So have you considered that, or will you consider that?
Okay, so with respect to that, the DSA2 algorithm uses LDA topic modeling for clustering. And before we can do that, we have to convert the documents into document vectors. So that's one area where we do that. With the DSA3, now see, because of space, I couldn't show all this information on the slide earlier. We convert the document into TF-IDF vectors for k-means clustering in step 6. We also do something similar in step 3 with dbScan, and we do that because dbScan helps you, or can help you, identify outliers. And this was kind of an experiment to see how well that would work.
Yes, yeah. We use dbScan for author-name disambiguation. It's so okay. The TF-IDF or the MB25. So these two algorithms, they are still based on the surface forms of words, but like it cannot let's say a car or a vehicle. So these two words, they have very different spellings. So this BM25 TF-IDF will not capture that. But
that is true.
Right, the semantic models like BERT or
yes, or something like T5, or even just doing word embeddings. That would be
word
helpful
embeddings.
As well.
Right.
Yeah. that is something, and honestly, that's something I'd like to do for future work, because that fascinates me. There's a guy that I work with in the proto team at Alamos. His name is James Powell, and he is all about word embeddings, and he's taught me so much. I never got to figure out where it would fit in here. So
Yes.
that's an area I would love to take this, because I think there's a lot of value in the semantic similarities between the words.
Right. Okay. So next question is that so the sources of your document come from Internet Archive or other archives, but when they are collecting this information from online, there is a problem of authority problems. So how do you deal with fake news and misinformation?
Okay, so I'll answer that with the question, what if the entire collection is fake news? Our goal is to try to summarize what's there. So if we have a collection about, and I show a variety of them here, you know, there's a variety of human rights collections here. One of them may contain fake news. And the goal is to summarize what's there, not necessarily try to figure out what the archivist should have done. In some cases, I know Mark Graham from the Internet Archive. He maintains several collections. He's trying to capture fake news so that people can study it, and so that in itself is useful. It's the thing is that yeah, as Dr. Nelson points out, we're actively trying to summarize these collections as they exist, and not really the Internet Archive at large. Now we can use the tools with the mementos from the Internet Archive, but somebody would have to find, they basically would have to make their own collection of the mementos that exist in a web archive at large, and then feed them into the tools to summarize that, if they wanted to do that. That's the goal. So in that particular case, if they insert something like fake news, then we're assuming they intended for it to be there.
Okay.
Now,
to generate, to build something that is really useful, you do need to take that into consideration. But maybe, in the future, you may want to integrate some misinformation detection tools to mark this web pages which may contain misinformation, to warn user to be careful when reading these pages. And also, you may want to eliminate the pages that can have a high probability of become fake news or something.
Yeah, I agree. That is a great idea. I remember having this a similar conversation with someone who worked at Bing, and they were interested in not fake news so much, but they were more interested in finding the bias that existed in particular pages. That's another thing that we could do.
Yeah, political polarization.
So if we had a tool that could insert this into the process, say while we're, let me bring up a visual here, while we're generating story metadata, or even generating document metadata, we could update the surrogate or the resulting visualization, whatever form it takes, with that information. So there's no reason that we couldn't add that capability to Memento Embed or add it to Hypercane or something like that. It's something that could be included. It's definitely within our existing storytelling process to include additional metadata like that.
Okay. So next question is about metadata extraction. So your title is generate the document metadata, but I'm a little bit confused. Do you extract them or do you generate them?
Well, there's a reason I chose that term. If the metadata is there, we extract it. If it's not, we have to generate it in order to produce a deep surrogate. So that's why that term was used.
But so how do you know if the metadata is there? So
it would be in the HTML. So the document metadata we're referring to are things like the OG title or OG description Or in the case of OG description, it'll even fall back to the older HTML description field that exists.
Okay.
Which is something that Facebook and Twitter won't even attempt to do. One of the other
Okay.
things that was coming out of the analysis of metadata study was that there are other fields that may be useful for consulting to get this information. There's different news sources, like one of the things I wanted to include in our surrogates but couldn't find a reliable way to do so was authors. If there's an author there, I do want to credit them. So I found out the New York Times, it stores author information under a metadata field called BYL for byline. They're the only one that do that, as far as I could tell. Other people use the actual author field that HTML provides. So the goal would be and maybe for some future work, to try to find which fields make the most sense and which ones a tool like Memento should be consulting in order to produce this. But if the metadata is not there, then there's very little we can do. We could do something like analyze the text and possibly extract things like the author. And I just use author as an example because it's something that's hard to find.
Yes.
We could use something like, I think Newspaper 3K tries to do this, but it doesn't always do a good job. We need something for at least analyzing news that's more like Grobid, where Grobid can analyze scholarly documents and extract things like the author. It would be nice if something like that existed for news sources. But this involves somebody researching these news sources and understanding how they set up their pages so you can scrape them appropriately, because that's really what it comes down to, is scraping. And whenever we're left with scraping, there's going to be mistakes, and it just becomes a problem. So
yeah, well, one potential way to do it is to use the NER techniques to extract all the people's names from this article and then do some classification, supervised classification.
That's a good idea.
Yeah, based on their appearance, positions, or some other features. So, okay, so last question is about about the random forest classification. So can you go to that page?
Was
the
this
page
for
where you
the...
showed a lot of curves?
Oh, okay. Let me.
Yeah,
that was for the images.
Right, for the images.
Oh, no, keep going. Yeah, here you go. Maybe here. Maybe that would be better.
Yeah,
Okay.
This is better. So here you use random forest as a regressor and not a classifier, right?
Oh, no. This is well, let me think about this for a moment. We weren't trying to predict a floating point value. We were trying to predict the probability that the image would fit into a particular class. And the class being, image as selected by author, or image from metadata, I think is.
Okay, so you do use the binary classification. You classify an image into one of two classes. Yes. Right, and
then we take. Oh, sorry.
But then usually for this classification problem, people will report the precision and recall. So I'm trying to understand why you're reporting the precision at 1 and the mean reciprocal recall.
So precision.
Or do you treat it as an information retrieval problem?
Yes. We are treating each document as if it's a query, or sorry, a set of results, and trying to determine which result, in the case of the images that exist in the document, which of these are relevant. And we only consider one of them to be relevant. Well, okay, we consider one of them and those that are equivalent images to be relevant. Those are the ones that the author chose. So that's why we approached it this way, because we have this scoring method, and this seemed like it was the best way to process a bunch of images and figure out which one was best, because we only care about one. We can only social cards only have one image that they represent typically. So that's why we approached it that way,
Okay,
rather than trying to bring in scores like F1 and stuff like that.
I see. Have you compared it with other works, or do you see some similar works that are trying to select the most striking images in news articles?
There were other works. The one that I brought up earlier was by Coe and Kern, and for some reason their name sticks with me. Theirs was interesting because they also did news, and they tried to do what they referred to as research works. Their research works were actually articles from things like Scientific American or the web pages of Los Alamos, which I thought was strange. They weren't doing things like scholarly publications, which is why the paper here differentiates, because we actually went into scholarly publications. But Coe and Kern did an interesting thing with HTML pages where, like I said, they try to find, based on the document object model of the web page, where the largest section is in the page, and they consider that to be the article, and then they choose the largest image that's in that section that has the most square aspect ratio. One of the critiques that I have is I think they only analyzed like a handful of pages, and they determined whether or not something was striking, or my term striking. I can't remember what they called it. They used grad students. They basically asked grad students to evaluate whether or not an image was striking for a page. Whereas we, on the other hand, differ by using the actual metadata fields supplied by the authors themselves for what they intend to supply. So where they were trying to predict, and I know it's subtle, but they were trying to predict what a reader would consider to be the striking image, whereas we were trying to predict what the author intended the striking image to be, and to see which method did that best. And this was one of the critiques I have of the other work that came before us. They essentially, and this work predated when the metadata was available. So we were the first to kind of think of this idea of using this metadata as the ground truth for selecting striking images. So that's another comparison.
Okay, good. Thank you very
Thanks.
much. Yeah, that's all my questions. You did wonderful work.
Thank you, I appreciate it. Honestly, I want to give you a little bit of credit. You and I had a conversation about scholarly publications. I think when you were at Los Alamos a couple of years ago, and that started me thinking about this problem, which is how we got to this. So I really appreciate you planting the seed there.
Sure, I'm glad I was helpful.
All right, Dr. Weigel, Dr. Jai Ratna.
I can go for next.
Okay.
Sean, you talk about the personas. Okay? So yeah. So I just want to kind of think about, like, how you use personas here. Is that just to kind of explain, different ways for them to kind of understand the collection usage, or is there anything else, that you use the personas for? Some other ways. Is that help you to kind of design your work?
So this is an idea that I actually got from Agile software development practices. The thing is, we started off with what became Natasha, and this was the initial problem. And the more I spoke to librarians and archivists and other people in the field, the more I began to realize that people weren't just looking to compare collections, but really expose them and discuss them, which is one of the reasons why if we could share these things on social media, it'd be so useful, because you get the comments and things like that. Well, that alone is a different use case than just what Natasha wants to do. And so I started trying to cluster these ideas together based on the conversations that I had with these librarians and archivists and curators and other folks. But this is an idea that kind of comes out of the software development where you want to have a picture in your mind of who you're developing the product for. And I know this seems silly because this isn't about developing a product. I mean, we're doing research here. We're trying to solve problems so that other people can develop products. But I think that this is important because it helps us understand what problems we're really trying to solve. And this is what helped guide me. So that's where the personas came from. I'm not an archivist, you know, or at best I have time organizing my own music. So I don't have the expertise that some of the people have that I talk to. But that's where the personas came from. So I wasn't able to use anyone that I knew specifically, and I didn't want to call anyone out. So that's why the personas.
So did it help you throughout the process, you know, coming up with these designs, or is that, you know, you try to kind of connect the personas back once you realize that, okay, I have these different scenarios, you know, different people have different collection understanding needs, and you try to kind of connect it back, or you kind of start off with that. So I'm trying to understand, because I like it, but I want others to kind of use it, because I'm coming from its CI side. So I like this concept of personas, especially from requirement analysis side. We start off with this, right? We always try to think about the users when we are developing stuff. So that's what I want to understand, like, you know, I mean, if you, you know, where you're coming from, like, you know, whether you kind of use it, you know, how it helped you.
Well, I think, like, okay, so when I've designed software applications in the past, it's an organic thing, okay, and that's how it happened here. So the first person that we had was Natasha. We didn't have a name for her, but we had that particular use case in mind. And then as we learned more about the problems and more about the problem space and more about who we were solving the problems for, that's where the others kind of came about. And honestly, the names didn't come about until within the last year. If I was to go ahead and do requirements analysis like you're talking about, and design a project and start working with a bunch of developers or something, I would come up with these much sooner with the help of the requirements analyst, because I think it's important for the folks who are implementing a solution to have some idea in their mind of who it is they're actually, you know, doing this for. When I worked for the Navy, I mean, we had the image in our mind was of various sailors that we had encountered, and we would talk about the problem in reference to, oh yes, and you know, Bob needs this for that reason. So I think it's a very important thing to do, but I know if you can say that someone should start from day one with the personas and then move forward, because, you know, research kind of takes a circuitous route, so to speak. I know it works well with software engineering, which is why I felt confident doing it here. But I'm not sure. I think what you could do is, if you start off with a research project with someone, you could, and I'm just mirroring this from my experience here, you could start with the one set of use cases and then give them a name. And then as you learn more, you realize that you have another persona. And that probably would have been better for me to have done along the way. We could have talked about Natasha for years instead of for just the last year. So that's what happened there. Did I answer your question?
Yep.
I felt like I wound a little bit.
Right, that's fine. Yeah. And so you have this the seed curve and the diagonal. You discussed that area and the curve about that. Right. I mean, some things probably not going to be there on the slide. Some things probably there, but I want to kind of understand, because you talk about these, like getting these seeds early and mementos, right? You know, yes, exactly that particular slide. You talk about these, you know, what you observe, you know, from the percentage point. But is there something that you can share about these, you know, from your understanding, like which one is more important from these observed behaviors? Because I was trying to kind of understand, you know, which one really works, because from from the way that I look, whenever I see this, what comes to my mind is a rocker. So I like to see
It's very similar.
something that, right, that hugs the ceiling, the wall and the ceiling. So I was trying to kind of see, I feel like the one that having the seeds early, having the mementos early, help that curation behavior. I mean, later on the collection itself, right? But is that the same case, or is that something you're looking for to explain here, or you just merely observe from the collection point of view what you see?
So this is just what we see. And I wouldn't want to prescribe how someone should curate their collection because these collections come into existence like we see here. Now, what this might represent, and I'm only speculating, so for people in the audience, please don't say, well, Sean said this is right. No, this is just what happened here. This collection had some curator or curators who added 30% of the seeds when they created the collection. And then later on, they added more. I think this represents people learning about the problem space over time. This also represents changes. So in this case, it's University of Southern California websites. So you have maybe new web pages came into existence. They're like, oh yeah, we should capture that. In other cases, and I don't have any good examples here because I'm kind of kicking myself. In the dissertation, I have a number of different growth curve behaviors. And it's interesting to see because you can tell when possibly somebody lost interest in a collection and then maybe another curator came on and gained interest in it. And that's not necessarily bad, that's just how it is. Let me see if I can make this visible because this is this is the dissertation. I'm zooming in on the wrong slide. Okay, that's not helpful. So what we document here are these different behaviors. And you see how, like, now you were thinking of the rock curve because you were like, oh yeah, upper left-hand corners. But the point is that we see that 34.83% of collections have that behavior, where most of the seeds and most of the mementos were added early. These are ones like this Idle No More collection by the University of Alberta. And I think Idle No More was a publication that's connected to the university. And that's why you have the seeds and then you have the mementos, which are gathered more slowly and closer to the diagonal. You also have folks like the Northern Illinois University here who have the seeds added in the beginning and the rest is more close to the diagonal. To me, the diagonal indicates, well, to me, what the diagonal does indicate is that there is a continuous crawling of those seeds. Sure, some seeds are being added here by the Northern Illinois University, but we have continuous crawling throughout this collection's life. And I think that's important because this is a collection that I would select if I wanted to analyze these particular seeds and wanted to have a good chance of catching them at different points in time, or catching a lot of them at different points in time. Whereas you have other collections where you can even get to something like this, where in this case, we had a number of seeds. I'm trying to, the one on the right. We have a number of seeds that were added early at the beginning of the collection's life, maybe more than 10%. And then after a while, somebody came on board and added another 10%. But by that point, 70% of the collection's life had gone by. And so these are the sorts of things to see happening with these collections. And we want to be careful, though, of not exposing information about the organization that's doing the collecting, because these sorts of things might give people ideas about when changes in jobs happened or something like that. Maybe we don't want to expose that. It's also possible that that maybe this person was working on a different project for a while and then was able to come back to this. So there's
Sean,
these different behaviors.
It's probably worth explaining for those unfamiliar with Archiveit. It's a subscription service. It's really nice service, but it costs a good bit of money, and there is essentially a crawling budget that the archivists have to be aware of, right? So you don't just add everything under the sun and say crawl every 10 minutes or something like that, because nobody can afford that. So it sort of forces them to make decisions about what to add and when to crawl.
And these curves sort of represent how they made those decisions and when they made them.
Right. So related question with that, when you discuss about the prediction of that semantic labels, right? So you kind of mentioned about that 4 things. Did you really consider like what's going to happen to those? Like, did you really try to see, because one of these growth curves are some of the features that you consider, right? Did you really see that how each of them going to affect those prediction? Because you just put a number there, right? Saying that, okay, 0.7 something F1, but it doesn't really say like, how those particular changes of these features going to affect getting that particular performance of your classifier, right? Did you really look at anything, or is just that you put everything together? Like all
we did
features?
put everything together initially.
Yeah.
So let's see here. I know I put this, I'm pretty sure I put this in the dissertation. It might have been moved
139.
around.
Yeah.
Was it one? Yeah. So around here, we talked about doing the predictions, and we have the rock curve and F1 and so on. And then, darn it, this is the problem with trying to write a dissertation out of a bunch of papers, right? Somewhere, it might be in the source paper, we went ahead and analyzed, and I find it here, we analyzed the correlation between the different features and these classes, and to try to figure out which ones to remove and see if we still got a decent prediction.
Okay.
And I think we found that the number of mementos really didn't make a whole lot of difference. Mm-hmm. What I am intrigued by is the fact that the curve did seem to make difference. And one of the reasons why we, I'm sorry, what was that?
No, that's what I was kind of thinking, because we can see that there's those like different types of curves can make a big difference on when you make the predictions, right? So that's what I thought, like that's why I was kind of curious that why it did not make a much difference in the results.
Well, the curves, I was expecting them to make more of a difference, because I was thinking ones like this, which show the 2 lines. I realize it's not as pretty as it could be, but the 2 lines are really wrapping around the diagonal. And what this represents is, okay, so this is Waldo Canyon fire. Okay, this is an event, right? This is an event that I believe this is one that's unexpected. And so the archivist or archivists is adding seeds and then crawling them, and then adding more and then crawling them, and so on and so forth. This is the behavior I expect to see with this type of collection, because we're learning about the event and we want to preserve what's there. And we may not care about getting different versions of the same seed. We might be okay with just one, because the idea was to capture the news coverage at the time of the event. And so I think this represents that kind of collection very well. But it's not the only kind of curve we see with those types of collections. Sometimes we see things that are they're like this on the right, where or this in the middle, where the crawling happens, but all the seeds were loaded up front. But we often find that collections like that are limited to like a week. They were only collected for a week, whereas other things might have been collected for years or months or whatever. Some of the collections in Archive go back decades, but that's because they front loaded them with a bunch of mementos from the Internet Archive. So it does make a difference. It just doesn't quite make the difference as we intuitively expect it to. And yes, I do think that one could dive into that further and try to find where these things are connected, because the fact that random forest is the classifier that seems to do very well with this, what that tells me is that there's some decision trees that exist that probably that we can read to go through and figure out what is weighting this in a particular direction. And if we could review those trees, maybe we can rules out of it rather than relying on the classifier to just, kind of do the work for us. That's the sort of thing I think would be an excellent follow-up study to this.
Next in the line, right? The PhD student.
Yeah, that's true. I mean, honestly, the growth curve thing was something that Yasmin didn't get to, sorry, Dr. Al-Nomaini did not get to. So that was the beauty of that.
So the last question, I think Dr. Wu also kind of get to this a little bit. So you talk about this off-topic detection. You consider with TF-IDF with the cosine, dice similarity, LSI with cosine, and all these. But you said you really did not consider the semantic part of it, right? When you're looking at these differences.
No, that would be next. That would definitely be helpful. But the goal here was to try to find something that would be that would not only just run fast, but would be kind of easy to accomplish this. I do think that one could do. I mean, like we were talking about, you could bring in BERT, you bring in T5, and if I can ever get a chance to time with GPT-3, I'd love to do it. But the point is we could bring these things to bear with this on this problem, but then we start getting into questions of, okay, cool, we get an F1 score of 0.788 just by counting the number of words that are different between the two mementos. If we get a better accuracy by including something like BERT, that's great. But how long does it take to run? And so then we can evaluate it in terms of performance, or not just in terms of accuracy, but also how quickly we might need to do that. Now, in this particular case, I don't know if we worried about that as much because of the number of documents that we have to go through in order to process these collections, but it would be an interesting metric.
Right. So, but the content in this case, the amount of terms going to be smaller, right? What you're considering here when you're doing comparison, right? Because I'm trying to think. You mentioned that LSI didn't really give you a difference, like TF-IDF and LSI both did not give you much of a difference. So that's why you went with the word count. I was kind of
I was surprised at that. I'm sorry to cut you off, but I really expected, because Al-Nomaini found that cosine similarity was it, but she, I mean, we tried more thresholds than she did. We tried more values, for determining what the differences between the two documents. I think she only did 20 or something like that.
Right. Yeah. I was thinking if it is smaller, probably LDA gonna work much better. I know LSI is faster, but with the lower accuracy, I'd say probably doing something. I mean, you don't need to go into something like BERT, but doing LDA on top of this, you can do a nice comparison and see whether there's improvement on that.
Well, I do agree.
Can I jump in and mention a related question that I had? The problem with going later is that all of your questions get asked. But related to this, my question about this is, did you get a sense of how many of the off-topic pages in her gold standard data set were actually that the topic changed rather than being it was hacked or it was down or something like that? Because if only a few of them were in that case where the page had content and the topic changed, you're not going to get a big win by doing anything.
That is true.
So
that is true.
Do you know the percentage of those?
No, I do not. And unfortunately, the data set itself didn't identify that. It just, I think it was 1 for on topic, 0 for not. And that was pretty much it. That would be some additional interesting work, because I expect that word count would work very well for things like the 404 page. I mean, that is clearly much smaller than the web page that has content, or the one that's been suspended. Maybe not so much for the hacked page, but depending on what the hackers put into the page. And it surely will not work as well for a page that's the exact same size, but now has different content. So I do agree. It would be useful to go through the data set and try to figure out which of these categories these things fit into. I did notice when I was looking at the different work for selecting exemplars that some folks did some analysis to try to figure out how to classify things like images into different categories. And I'm wondering if somebody could do that sort of thing here. Okay, so Dr. Nelson reminds me that in collections, there's a responsible archivist working under a budget, so wildly off-topic pages are likely to be culled. That is true. That is the other thing that I noticed, Dr. White, is that there actually are not a whole lot of off-topic pages in these data sets.
Well, but the difference is it's not an off-topic seed in a collection, but it's a memento that
That's
has
true.
gone off topic. So, you depending upon how often these are being crawled, somebody would have to really be on the ball and, checking all of them to make sure. And, once it gets archived, I don't think you can remove it from archive it. So yeah, you may get one off topic and then they realize, oh, whoops, I need to stop grabbing this page. But
now see, you mentioned that, and I realize that's supposed to be the case. And I've never found any documentation that runs counter to that. But oddly, I've tried to revisit some of the mementos from this data set, and they don't resolve anymore. I mean, it's a small number of them, but I wonder what happened there. And this kind of gets into, I think it was Muhammad's research, where he was trying to study.
That's Muhammad's dissertation.
Yeah, but the thing is that something happened to those mementos. So I'm wondering if they did remove them from the collection, or if there was somebody that they could call and say, hey, could you edit this work for me or whatever. I don't know. Of course, it's entirely possible. Maybe that was just a bad day for me, and I shouldn't have been visiting Archive it that day. I don't know.
So that's all from me. Thank you.
All right,
thank you. I appreciate
it. You're next.
Hey, yeah, sure. Happy to. So Sean, thanks again for your presentation. This was awesome. I have a few questions for you that are, technical, speculative, and even philosophical. Awesome. So you outline in your dissertation that you basically qualify your DSA selection process by implementing the search engine, right? Generating search queries based on the collection, and then you quantify the retrievability of those mementos that you select. And that's great, that's fair. My question is, what sort of documents did your search engine implementation retrieve that your DSA algorithm did not select? Right, so basically the opposite of your retrievability analysis. Do you have a sense of how significant those potential exemplars were for your story, and why your search engine implementation did not grab those?
Oh, that is a good question. Let me think about that for a moment. I did look at some of these.
So that's based really on the assumption that your result set from the search engines is larger than your exemplar set, which I assume to be true.
Yes, it is. Yeah, remember we're trying to get around 28 exemplars per story, and this changes depending on the size of the story. And I go over that in an equation that's in the dissertation. But let's see here. If I've got something on this, one of the problems that we have with web archive search engines, and anybody who's looking for a topic to work on for their research should probably tackle this. Well, here, okay, these are exemplars that were surfaced, but that's not what you're asking. Where is it? Yeah, I'm sorry, I didn't make a slide for this particular thing, but there's an example I have here of Archive it. And I realize Archive, maybe I should go back to, yeah, I'm just going to do Archive it. Do I mention it here too? I'm just showing Solar Array back. Okay, so it's Archive It that I settled on. There is a problem with searching for mementos in Web Archive search engines. And that is you can type in a query, and it's something like Archive It, and Solar Wayback operates the same way. And you'll notice I typed in a query, and unlike a search result that you would see on something like Google, you have the same page repeated a couple of times. Okay, so you don't see it here, even though it says Mars Facebook twice. Those are two different original resource URIs. But what we see over here on the right is the same original resource URI repeated over and over again. And you're like, okay, so is this a mistake? What does this mean? These are different mementos. These are different mementos at different times, looks like on the same date for this particular page. And so a lot of the search results that Solar Wayback returns are like this, unfortunately. So it can be difficult to try to say that you're going to find something in the first 10 blue links, the first 10 search results, because you're going to get a lot of mementos that are the same page. So that is one reason why the result set is so big that's returned by the Web Archive search engine. So that sort of answers part of your question about, did I review some of these? Yes, I did. And I found a lot of repetition in these, which is another reason why we even go out to 1,000 search results, because we're trying to see just, do we eventually get to all the exemplars? Even though you have a lot of these repeated pages in here. And these are not technically really repeated pages. These are mementos. They're different versions. There are different derivations of the same page. Yeah. So that's
maybe a quick follow-up question there to that on the technical end. If you had created search engine queries, not just from your exemplars, but from the entire collection, would that have changed the picture?
I forgot about that. Yes. Okay, so I was not entirely accurate with what I said on this slide. We did produce queries from the exemplars, but we also included an additional query with each one of these query types that was derived from the metadata of the collection. That is something that I mentioned in the dissertation and I did not bring up on this slide, and I apologize. Yes, we did incorporate the metadata from the collection as well. And I chose collections that had some metadata, because remember, there's not a lot of collections that have a lot of metadata. So we were able to do that particular part of the experiment. And we still got these results. Or sorry, these results.
Okay, that makes sense. Makes sense. Thanks.
Yeah.
So maybe more on the speculative end of things. Arguably, summarizing multi-topic collections is more difficult, and the outcome may be not all that useful. However, if you could speculate what you would expect to visualize with all your tools of the entire DSA toolkit on a collection of lanl.gov, the outward-facing Los Alamos National Laboratory website, what do you think you would see?
So my initial inclination here is to lean into what I discussed kind of in the future work section of the dissertation, with a concept that that's been introduced and revisited several times in information retrieval. And I haven't seen, I mean, it's probably had traction somewhere, but I haven't seen where it's been picked up. And that is the concept of scatter gather. So if we could tell a story from built based off of LANL's external website, maybe the first, but it would be a story of multiple pages, okay? And the first page would give us an idea of the different research areas. You might have the folks who are working on weapons and the folks that are trying to, defeat COVID-19. And then you have the folks who are focusing on environmental work. And then you could click on each of these topics and then go visit a story that reflects the work being done in that particular area. And the neat thing about scatter gather is that it does go both ways. Once you get down to a particular point, and you get to a story where you've got a lot of very specific content, you can then click on a link to get back up to other topics and then kind of explore it that way. I realize it sounds like you're just going through the website, but because of the way that the surrogates are generated and because of the way that they're presented to the user, it gives them an interactive method of gathering the information that doesn't take as much time as just reading a ton of documents. So that's my first inclination for how I would present Lanol's work effectively, instead of trying to produce something like we have here, where that's not maybe something like we have here, where it's just one column. We have some vague notion about what's in it, or we have a pretty good notion because this one has some decent metadata. Thanks, IAPC. But the point is that this story, I think, is sufficient because there's a lot of homogeneity between the mementos that are in this collection. Whereas on the Lanol website, like you said, there's different topics, and that's where I would go with something like scatter gather, or maybe multiple stories and tie them together or something like that. I don't know. Yeah,
I think the meta story on top of stories, like an inventory table of content sort of thing that lets you tree-like dive down into sub-stories. I think that's a good idea. Yeah.
But the important thing is that for it to be effective for this, and I mentioned this a bunch of times in the dissertation, but I didn't want to overload the audience with terms, is that meta story needs to have good information sent. That means that it has to have information that is meaningful, that convinces the reader of what's there. It gives them a good idea of, it's got to be accurate, but it's also useful, as some other people have studied, whose names escape me at the moment, Capra maybe, anyway, where the multimedia part of the experience is key to people understanding and learning about what you're trying to present them. So that's the other reason, the other thing that I wanted to bring up. So.
Yeah, that makes sense. Thanks. All right. So next question I have is also speculative. Could you please navigate to slide 35?
Uh-oh, he's got a number. Let's see here, 35. Okay.
So looking at the slide, you kind of know what's coming, right? If and when you're successful here today, you're in the business of mentoring the next generation that takes your work and moves us forward. So talking about RQ 5, 6, 7, and so on and so forth, on the box on the right where there is no RQ indicated, can you think of research questions related to visualizing and distributing the story?
So one of the things that I am very disappointed that we didn't get to do, and this was some work with Dr. Jayarathna and his students like Gavinia, was we wanted to do user studies to evaluate these visualizations and figure out what presentation worked well. And we never got to that because of COVID-19. But that would have been my first thing that I would have wanted to do for maybe research question 5. Because there's all kinds of ways that you can present. I mean, we found social cards work well, but do we present them in order of date or publication, or can we put them side by side? I mean, what size do we make them? What if we want to include more than one image? I mean, there's just all these questions about presenting it and trying to figure out what worked well for the person understanding the story. And we never got to do that. So that's the first thing I would come up with for research question 5. Also, for distributing the story, we might want to look at which platforms have a decent visualization and how that reflects on users. And we might even be able to flip this around and look at the story as it's distributed and figure out how well that might inspire archivists to create other collections on the same topic. I'm not, and then you get into the idea of maybe capturing the story as a memento, which goes into a future collection about the topic. And I wonder if there's something in designing a user interface that incorporates these elements so that an archivist can create a collection better. You know, where better is not something I know what that means. That's something that a future researcher would have to define.
Mhm.
So I think that these are some areas where we could tackle visualizing and distributing the story and find future research. One of the things I'm also interested in is trying to move away from, and the archive it people are going to be unhappy with me, but this interface is great. It lets me search through the collection. When people add the metadata, the facets are wonderful. I love facets. I think they're great. But I wonder if there's a better interface that we could come up with. And we also have an interface that the, see if I can find it in my backup slides. Just give me one moment here. Here we go. We also have an interface that Archive It presents to the archivist so that they can, add seeds and put other information in here. I wonder if this could be improved and if there's some way we could make that better, and we could do a study with that. And I realize this isn't technically part of the storytelling framework, but it's something that that I think deserves some research and some questions.
Yeah, absolutely. Couldn't agree more. Thanks. Part of the reason why I thought about this is looking at your DSA puddle, which is incredible, which is awesome. And I was surprised to see the chronological order basically in form of a resume, right? You start in the present, or actually you start in the future and you go to the past. So those are questions that are interesting to consider in this context. Okay, cool. So lastly, I have a philosophical question, and I'm not sure I should apologize for that or not, but anyways. So could you please join me on a journey to compare your work, your DSA and your summarizing work, with other summarization concepts that we're familiar with? Specifically, I'm thinking, because you wrote a paper about spoilers on TV series, can you compare that to the summarization concepts of a movie trailer?
Okay, so yes, and this is something that Dr. Nelson and I both enjoy fiction, and we talk about this a lot because that's ultimately the goal, right? The thing with the movie trailer is it's trying to select exemplars, but they are exemplar scenes from the movie to convince you to come watch the movie. That's their goal. It would be a more it would be a little bit more helpful if they try to summarize the movie, but in reality they're trying to make it seem more enticing. So anyway, if we just ignore that and we say that we want to summarize a movie with these exemplars and create this trailer, then yes, that is very similar. Of course, selecting video is very different from processing text, and honestly, that's one of the things I'm hoping I might be able to get a glimpse of as I'm working with CCS3, because they're looking at processing images, and I want to try to understand maybe how we select these clips. For not for trailers necessarily, but we want to get there one day. So it is similar and different at the same time. Movie trailers, like I said, consist of little video clips, but they have to be put together well. You want to make sure that you're not cutting people off while they're talking. Those sorts of things people have done research on to try to figure out when you have the rise and fall of the audio in the clip. So you could probably do that sort of thing. People also use it to try to skip commercials on TV shows. So we know that there's some work that's been done there, but that's just one small piece of trying to assemble the trailer together. So there's been a lot of work on selecting exemplars, and it really gets more complicated when you consider trailers for TV shows, because there are different types of trailers that exist for TV shows, just like there's different types of stories that you can make with web archives. For TV shows, you have the trailer that exists to try to get you to watch it. And that's the one that they show as part of the commercial. There's the trailer that exists at the end of the episode that's supposed to summarize the next episode. Its job is not just to try to entice you to watch it. It's expect you have some knowledge already because you already just watched this episode. And then there's another kind of, it's not really a trailer, but it is a summary. And that's where they present you last time on, and they give you an idea of information that you need to know to consume the episode you're about to watch. That has an additional input, and that input is the episode you haven't seen yet. So that would kind of be like, inserting a search query and generating your web archive story here. It's a way to influence what was selected. And so that's a difference for the trailers. So that's just a start. I could probably go on about this for a while.
Yeah, no, and I'm sure all of us can. But yeah. Just one brief side comment there. I find it fascinating, the temporal aspect, to consider these temporal aspects on these things, because as you said, right, for trailers, they may or may not violate the timeline of the movie. The same thing for previously on, like in review of an episode of a series, those sort of things. Interesting concepts to consider when you're summarizing text and mementos, maybe as well, right? Depending on the intention, I assume, of the summarization and the story that you're trying to tell.
And you bring up a very good point. In the case of entertainment, like TV shows and movies, when you're creating a trailer, you don't want to include spoilers. So now you have exemplars that you have to exclude from consideration at the beginning. And how would a machine know what that is? Somebody would have to say, no, you can't go between minute 23 and minute 27 of the movie at all in the trailer. I'm not sure how a machine would know not to do that. I mean, once we create a machine that could figure that out, then we have to start talking about robot rights and stuff like that. So that's another issue.
Okay, great. Thanks so much.
Okay, thank you.
Dr. Weigel, do you have any material left since you joined last?
I have, just for the sake of asking. This has been, you did a great job on your presentation, as everyone has said, and this has been a great
thank you
discussion. But to get to just a more mundane question, so when you're talking about, going back to the collection curves that we've talked about a little bit, and so.
Okay.
You've said that one of the clustering techniques takes into account the collection curves, and it looked like maybe the k-means clustering did that. I think it's in your backup slides, like maybe 115 or 151. There you go.
Yeah.
So can you talk about how that takes into account the collection curves?
Okay, so
there?
Yeah, that's a great point, and I was hoping I talked about this effectively here, but to do this, I really am kicking myself for not creating a slide that had all these curves on it, because I made them repeatedly. Here, okay. So what I quantified in the dissertation was that there are different types of behavior. There's different types of curves, and what we see here for E. Okay, this one where it says 1.30% of collections have the behavior seed continuously, seed memento continuously. Al-Nomani's algorithm does something called that she calls slicing, where she figures out how many mementos she needs, and she creates buckets based on that, and all the buckets are the same size. I use the term buckets just because I'm Southern, but the point is that they're containers for clustering the collection, but all of them are the same size. And she starts at the beginning of the collection, and she first sorts the collection by memento daytime, and then she takes the first memento and puts it in the first bucket, and then she fills that bucket up until it reaches the top, and then she starts filling the next bucket with a bunch of mementos based on memento daytime. For this particular collection type, where the mementos are along the diagonal, that works great. You end up with basically the time periods are all equally represented, because everything is represented based off of the collection anyway. But if you have a collection more like what you see on the right, this one that says 3.76% of collections, where the red line is skewing downward, it's clear that some of those mementos, if we use this time slicing method, will end up in different slices or in different clusters, even though they're from the same time period. And this was something we ran into when we were using the DSA1 algorithm to tell some of the stories. If we use k-means clustering, we can ensure that that doesn't happen, and different time periods of the collection are represented more effectively. So that's basically what we're trying to solve with that.
So then you're using the date time as the metric that you're computing the k-means on?
Agreed. Yes, that is it. Yeah.
Right. Okay, that was pretty much what I had left.
Okay. Oops.
All right. Last chance for questions from the committee. Anybody else? All right. At this point, we're going to ask everyone but the committee to leave. And we thank you for showing up and attending the defense.